Hello everyone. So welcome back to Math Zone African Motifs. We're gonna get into a new topic here, okay? So this is lesson one, okay? Thank you for tuning in again. So today we're gonna start. We're gonna do series and parallel circuits. Series and parallel circuits, okay? We're gonna do an introduction. So we're gonna use lesson one as an introduction. So now we're going to start with series. So let me begin with series. And I will discuss parallel afterwards. Okay. So we're going to start with series. Okay. So what is a series circuit? Okay. And how is it different from a parallel circuit? So a series circuit is one in which there is only one pathway. There's only one pathway for the electric current. Okay. So there is only one pathway. Okay. So this is what a series circuit is. Okay. So there is only one pathway for the electric current, unlike the parallel circuit, because in a parallel circuit there is a lot of pathways. Okay. So in a series circuit, there is only one pathway here. And that is what is important to remember about a series, and because that's what makes it different from a parallel circuit. So another important thing to know what? So the components are arranged one after another in a single pathway. In a single pathway. in a single pathway. So hence we say that they are connected hence we say that they're connected in series. Okay, they are connected in series. So one after another. So if the components are connected one after another, we say that in series. So in a parallel circuit, they are connected alongside each other. But in a series circuit, they are connected one after the other. Okay. So, and then, so a measuring device that we're going to use a lot here is an ammeter. So you should know what an ammeter is. What is? So I want to give you the definition here of an ammeter. It's because sometimes it can be asked. They can ask you what an ammeter is. Okay. So we say what? We define it this way. We say an ammeter is a measuring device used to measure the electric current in the circuit. So what it is measured in amperes. A. So this is the SI unit for current. It is measured in amperes. Okay. So the symbol for an ammeter, again, it will be connected to the wire. So the symbol will look like this. Okay. And then there will be a measuring device in the circuit like that. Okay. This is the symbol for an ammeter. See? Again, you should know. So let us look at a rough sketch. Let's look at a rough sketch of a series circuit. Okay. Let us say, so I want to show you a rough sketch of what a series circuit looks like. So now we start with a cell, and then we can have resistors here. Then we can have a light bulb. And then we can have another resistor here. And then we can have another resistor. And then we can have another resistor. So the resistors are connected one after the other. And then maybe we can have a what? An ammeter, you see. So the current will have only one path. So the current will go from this is the positive terminal and this is the negative terminal, okay? So these are resistors. Resistors, and this is a what? An ammeter. This is an ammeter here. And this is a what? A light bulb. A light bulb. This is a light bulb, and then so the current will go from a positive terminal around the circuit, okay? So the current will move out of the negative of the positive terminal like this, and then the current will go around the circuit. You see, the current will go around the circuit. At this point here, the current will be measured by the ammeter. So the ammeter will have a reading here that tells us how much current is passing here. But you can see that the current has only one path, you see. So the current does not take any other path besides the one that is moving on. Okay. So there's only one path for the current. That's what we mean because the components are connected one after the other. See? So that's what we mean. And then, okay. So this is a rough sketch of the what? Of a series circuit, okay? So what are the key points, okay? There are three key points that you should remember about a what? A series circuit. So we say this. The three things you should remember is that the first one is that there is only one pathway. There is only one pathway for electrons for the electrons to flow. And then the second thing that you must know is that the current flows at the same strength, okay? the current flows at the same strength, okay? Same strength in a series circuit, okay? The current flows at the same strength everywhere in a series circuit. Because so we say the current is the same at all points in the circuit. And then the last point here, okay? The last point to know is that so if you add more components, okay? If you add more components, if you add more components in a series circuit, the current will decrease. So more components will lead to a decrease in current, okay? So if this means that the opposite is true, what does this mean? Is that if you remove the current, the components, if you remove more components in a circuit, the current will increase. So the opposite is also true, okay? So I think that is a good summary for a series circuit, okay? So let's move on to a parallel circuit. Okay? This is a series circuit here. So let's look at a parallel circuit, okay? So now this was series, okay? Now let's look at parallel. So in a parallel circuit, so now in a parallel circuit, the current the current flows in multiple directions. In multiple directions. Okay. So it's not just one pathway. Okay. There are multiple directions. So the components are connected alongside each other. So they are not connected one after the other. Okay. Alongside each other. Okay. So we say that they are connected. They are connected in parallel. They are connected in parallel. So they're connected alongside each other. So we say that they're connected in parallel here. Okay. So now so the ammeter works the same way. So the ammeter will measure the current such that, but then the ammeter in this case will measure different currents. So the current strength is not the same here, you see. So what we can see here is that what? So the current strength, okay. The current strength will differ, okay, will differ for currents moving in different directions. Moving in different directions. Okay, so the current is not the same, okay, it will differ. Okay. Okay. So the current strength is not the same in this case, you see, unlike the previous part. See, the current strength is not the same. It's not the same current strength. So how does the sketch, let me show you the sketch. What the sketch of a parallel circuit would look like. Okay. So we have a cell, okay? Again, we have a cell, and then you can have a component here, a resistor, and then say now you have a what? A light bulb here, a light bulb, and you have an ammeter. You can call it A1, okay? And then the wire goes back to the negative terminal. So you have a positive terminal and a negative terminal. Then we have A1 and A2. So now the current will go, okay? The current will move from a positive terminal like this. Okay, let us, it will move from a positive, and then it will go through the resistor. And then at this point here, at this point, the current will move in different directions, you see. This current will go this way, and that current will go that way. So there are multiple pathways, see? And then the two currents will meet at this point, you see. And then they will combine and become one and go back to the negative terminal of the power source, okay? So there are, the current moves in different directions. In this case, you can see that, unlike the previous one where there is only one path, you see. So what we have here is that, so what are the key points? Again, there is key points that I, just like previously, we have three key takeaways here. The points that you should understand about parallel circuit, okay? The first one is that what? So there is more than one there is more than one pathway for current to flow. And then the second one is that the current divides, okay? As you've seen there, when it goes to different directions, it divides, okay? The current divides between the different branches. Between the different branches. Okay, the different branches. So, and then so the component here is that if you add more components, if you add more components in a parallel circuit, the total current will increase. Okay, so the total current increases in this case. You remember previously. So now, if you add more, it leads to an increase in current, unlike previously. Okay, previously, if you add components, then it decreased the current. Okay, so here we have an opposite, because previously what happened? We said that if you add more components in a series circuit, the current will decrease, you see. So in a series, it decreases if you add more components, but then in a parallel, it increases the more components you add. See? So the opposite happens. So this means that here, there will be a measurement here, okay? There will be a measurement on this ammeter here, A2, and then there will also be a measurement of current on ammeter A1. So now, if you want to get the total current, okay, AT will be equal to A1 plus A2. Okay, so yes, guys, I think let's leave it here for lesson 1. Okay, stay tuned for lesson 2. Okay, lesson 2 is coming very soon. Okay, thank you for tuning in um, into African Motives Math Zone. So guys, please leave your comments in the comment section. Okay, leave your comments in the comment section if you have comments or you have questions. Okay, for something that you don't understand so far. um, I will attend to you. Okay, so yes, let's leave it here. So this is the new topic that we're going to be looking at, guys. Okay, so I just wanted you to understand the key concepts here, and then the basics about series and parallel circuits. Okay, thank you for watching. Thank you for tuning in. I hope you tune in for lesson 2. We're going to continue on. So we're going to do some examples, okay, in lesson 2. We're going to do some examples. We're going to look at some examples that we will be applying here. Using this, applying this concept. So bye-bye for now, guys, and stay focused.